Now we can talk about sums of sequences. Sometimes the test will ask us for the sum of a long sequence. For example, what is the sum of all the multiples of 20 from 160 to 840? We'll actually talk about the answer to that question later in this video. Before we talk about that, a famous legend from the history of mathematics will help us figure out this sort of question. The great mathematician Carl Friedrich Gauss was known as the Prince of Mathematics, and he was precocious as a child. According to the story, the 5-year-old Gauss was pestering his kindergarten teacher with too many questions, and she wanted to keep him busy for a while, wanted to kind of shut him up with some kind of hard kind of question. She asked him to add all the integers from 1 to 100, and to her astonishment, Gauss produced the answer in seconds. How did he do that? Well, the 5-year-old Gauss noticed the following. Suppose we have all the numbers from 1 to 100 added up. Take off the first and the last. 1 plus 100, that's 101. Now take off the next pair remaining from the beginning and the end. 9 and 2 and 99, they also add up to 101. Then the next pair, 3 and 98, they also add up to 101. So you see a pattern here. We could keep on taking pairs from the outside. They would all add up to 101. And of course, there are 100 numbers, so that would be 50 pairs. Clearly, we could pair all the numbers up. We'd wind up with 50 pairs, each of which has a sum of 101. This means that the total sum has to be 50 times 101, which is 5,050. And that's exactly what the 5-year-old Gauss figured out. Let's generalize that to the sum of the first n positive integers. So the first pairing would be n plus 1. The second pair would be n minus 1 plus 2, which is also n plus 1. Then n minus 2 plus 3, which is also n plus 1. So each pair would be n plus 1. That would be its sum. And there'd be n over 2 pairs. So the sum of the entire sequence has to be n times n plus 1 over 2. That is the sum of the first n positive integers. That's a good formula to know. And again, don't memorize this. As we say often in these videos, don't simply memorize this formula, but if you understand how we got to this formula and how we put it together, that is real mathematical understanding. Even more generally, suppose we have any evenly spaced list that has n items with a lowest term of a sub 1 and a final term of a sub n. If we pair from the outside, each pair will add up to a sub 1 plus a sub n, the sum in the first and the last terms. If there are n total terms, there will be n divided by 2 pairs of terms, and each pair will have the same sum. So the sum of the list, we could write it this way, or we could write it this way. Either one of these ways is fine. This is an enormously important formula, and once again, don't simply memorize. Please understand how we built this formula step by step. Now we can go back to the practice question we had at the beginning. Pause the video and see if you can figure this out for yourself, and then we'll talk about it. Okay, we have to determine how many terms there are. So 160, that's 8 times 20. 840 is 42 times 20. So we're going from the 8th multiple to the 42nd multiple. And so how many terms? We have to use inclusive counting here. So inclusive counting, 82 minus 8 plus 1 is 35. So that's the number of terms. So the number of pairs is half of 35, which is 17.5. And the sum of the list, the beautiful thing is that when we add 160 and 840, we get 1,000. And so it's just 1,000 times 17.5, or 17,500. What is the sum of all the multiples of 5 that are greater than 100 and less than 200? Pause the video, and then we'll talk about this. This is a tricky problem because we're not including 100, we're not including 200, but we are including all the multiples between them. So 100, of course, is 5 times 20. That's not included. But if we add 5 more, 105, that should be 5 times 21. So that is included. And that's, in fact, the first term. Now go to the end of the list. 200 is 5 times 40. That's not included. But if we subtract 5, go down to 195, that should be 5 times 39. And that's a sub n. So we have a sub 1 and a sub n. Now we just need to know the number of terms. How many terms are there from the first term, which is 5 times 21, to the last term, which is 5 times 39? Well, it's the same as how many numbers are there from 21 to 39. And we get that from inclusive counting. 39 minus 21 plus 1, 18 plus 1, or 19. Now we have all the pieces for our formula. N equals 19, a sub 1 equals 105, a sub n equals 195. So we're going to plug this into the formula. I'm going to do the following. First of all, I'm going to add the first and the last term and get 300. That's a nice round number. I'm actually going to factor out the 3 and multiply it by the 19. So we get 57 times 100 divided by 2. Now I'm going to do 57 divided by 2, which is 28.5, because of course 56 divided by 2 is 28, 58 divided by 2 is 29, 57 divided by 2 is right between them, 28.5. And then multiply 28.5 times 100, we get 2,850. So we go back to the answer choices, and we choose answer choice D. To add sequences of evenly spaced numbers, pair the numbers by the first and last to produce pairs of a constant sum, then multiply by the number of pairs. Once again, I would urge you not merely to memorize the formulas given here. Instead, understand the logic of the procedures explained.